Morning, everyone. Sorry I am not there today. Um, no childcare, but we can still go through lesson 38. It's a brief lesson, pretty simple to understand, all based on the quadratic formula. And what we'll be looking at today is a specific part of that formula called the discriminant. And the discriminant is just the b squared minus 4ac, the part that is under the radical. It's actually pretty valuable in terms of telling us how many solutions we should actually have. So we'll go through a couple of examples and we'll leave the problem set at the end. So for A, I have an A value of 1, a B value of 0, and a C value of -9. So the discriminant is just B squared minus 4ac, so 0 plus 36. My discriminant value is 36. So when I solve this using the quadratic formula, I have 0 plus or minus the square root, and I've already got this discriminant value, so that's 36 all over 2a. So 0 plus or minus anything is just going to be whatever it is, so I'm going to have plus or minus the square root of 36 over 2, which is plus or minus 3. So I ended up with two real solutions for part A. For part B, my discriminant value again is b squared, so b being -6, -6 squared is 36, minus 4 times a, which is 1, times c, which is 9. 36 minus 36, which is 0. So my discriminant value is 0. And when I go to solve this using the quadratic formula, x equals -b, so -6 is +6, plus or minus the square root of 0, which I already have from this discriminant value, all over 2a. I just get 6 over 2, because 6 plus or minus 0 is just 6. X equals 3. So I got one real solution. And as this is a video, if I'm going too fast, feel free to pause or go back and rewind at any point. And I'll leave this up in Classroom for the rest of this unit. So C, discriminant value, b squared, b is 0, minus 4ac, 4 times 1 times 9. I get 0 minus 36, or -36. So when I solve my quadratic formula, I get 0 plus or minus the square root, -36, all over 2a. So 0 plus or minus anything, it's just going to be the plus or minus. So remember, the 36 is square root of -1 and the square root of 36. So it's 6i. Remember, the square root of -1 has a value of I, all over 2. So when I simplify, I get plus or minus 3i. So I have two complex solutions. So the big thing you're going to take away from this is I had a positive value, I had an equal to 0 value, and I had a negative value. And that's what the discriminant is going to do for us. So if the discriminant is greater than 0, I will have two real solutions. If the discriminant is equal to 0, I will have one real solution. And if the discriminant is less than 0, I will have two complex solutions. In other words, two solutions with a value of I in there. And that is the intent of this entire lesson 38. Let's look at a couple of examples. So example 1. What does the discriminant tell us about the number of solutions to the equation? So I have an A value of 1, a B value of 3, and a C value of 7. Remember, this has to equal 0, so I got to move the 7 over. So that is the quadratic equation I am looking at. So when I do the discriminant, b squared minus 4ac, so 9 minus 4 times 1 times 7, 9 minus 28, okay, negative 19. So I should have two complex solutions when I solve this. So now I have to solve this. X equals negative b plus or minus the square root. Already got this discriminant value done, so I've saved myself a little bit of time. All over 2a. Negative 3 plus or minus. I can't simplify the square root of 19, so I have I radical 19 all over 2. And that is as far as I can go in terms of simplifying. So those are my two complex solutions, negative 3 plus I radical 19 over 2, and negative 3 minus I radical 19 over 2. Pretty straightforward. That's all we're looking at. So we're using the discriminant to predict. So in this case, A equals 1, B equals 2, C equals 1. B squared is 4 minus 4 times 1 times 1. 4 minus 4 is 0. I should have one real solution. So let's take a look, see if I do have one real solution. X equals negative b plus or minus the square root. And I already have this b squared minus 4ac all over 2a. So I have negative 2 plus or minus 0 is just going to be negative 2 over 2. X equals negative 1. So that is my one real solution. So it worked out. And I could double check this by factoring. This would be x plus 1 times x plus 1. So we can see that x equals negative 1, multiplicity of 2. So negative 1 is the only real solution. Remember, if I have no middle term, my b value is 0. So b squared minus 4ac I'm going to get negative 16, so I should have two complex solutions. So when I solve this out, I have 0 plus or minus 4i over 2. So I get plus or minus 2i as my answer. So I have two complex solutions, which is exactly what the discriminant predicted I would get. So let's take a look at a couple more, and then we'll set you off on the problem set. So for C, b squared, negative 4 squared is 16, minus 4 times 9 times negative 14. So 4 times 9 times 14 is 504. So we have 16 plus 504, which is 520. So I should get two real solutions. Negative b is positive 4 plus or minus the square root of 520. All over 2a, which is 18. (520) simplifies down to 2 radical 130 all over 18. Whoops. And when I simplify that, I divide everything by 2. 2 plus or minus the square root of 130 all over 9. Everything's positive, so I have 2 real solutions. All right, I'm going to skip D. And we'll just look at E and finally F. Again, I want you to focus on the fact that this is not equal to 0, so I need to make it equal to 0. And now I can check my discriminant. B squared is 1 minus 4ac. 4 times 2 times 5. 1 minus 40. Negative 39. So I should have 2 complex solutions. Negative 1 is 1. My discriminant is negative 39. All over 2a, which is 4. 39 is 3 times 13, so there is no simplifying of the radical other than to take out the I. And that's as far as I can go. So those are my 2 complex solutions. And finally, F. First thing I'm going to do here is take out the greatest common factor. Because it's an equation, I can divide both sides by that greatest common factor of 4 to make my life a little easier. How to divide. 2x squared plus x plus 8 equals 0. So now my discriminant is going to be b squared, which is 1 minus 4 times 2 times 8. Which is going to be negative 63. So I should get 2 complex solutions. Quadratic formula, x equals negative b. So negative 1 plus or minus the square root of negative 63 all over 2a, which is 4. Negative 63, I can simplify as it is 9 times 7, and 9 is a perfect square. Negative 1 plus or minus 3i radical 7 all over 4. 1, 3, and 4 are not divisible by any number other than 1. Therefore, this is my solution. So if you didn't see the 3i radical 7, I got radical negative 1, which is the I. Radical 9 is 3. And radical 7 is radical 7. So that's where the 3i radical 7 comes from. It's pretty straightforward. It's that b squared minus 4ac, letting us know how many solutions we have, using the quadratic formula to get the actual solutions. But by doing this quick check on the discriminant, I've simplified what's under the radical already. So you guys are going to work on the problem set for Wednesday, numbers 2 through 8. Hope you guys have a great afternoon, and I will see you all Wednesday. If you've signed up for reassessment, make sure you make those appointments, get your corrections signed off on or fixed, and then make sure we touch base to schedule the actual reassessment, which needs to be completed by the end of the day, school day, Friday, 2:45 p.m. Have a great one.